Go to D2L, you'll see a URL for Flowchart. Click on that. Enter your name, and also, along with your name, please put CIT 1113A, so I know which class you're in, because I have what I call an A class and a B class. And then put your name, John Doe. Put your email address. It can be anything you want, but a Rose email address seems to make sense. Put your password in there, whatever you want it to be. If you want to make it your D2L password, that's totally cool. Nobody else is ever going to have access to these passwords. Then click Sign Up. How many people are getting in? Anybody getting an error message? Is that a yes? You got an error message? What does it say? CIT 113A in there. Okay, what you need to do is go into D2L, go to our web page, and follow the link on the top. We're creating accounts in lucidchart.com, and then fill in what you're there, fill in a name, but add CIT 113A to it so that I know it's part of this class, and give it a email address, whatever you want, a password, whatever you want. And that way, we can all draw flowcharts together. All right, if we're all in, do plus document. You ought to see that. And it'll sit there and it'll load for a minute. This is just going to be a real quickie introduction. Let's make a real dumb little flowchart. I'm going to start it with a terminator. So I'm going to click on the oval, the pill shape, put it on the top, and then I'm going to add the word start to it. Now I'm going to draw a line, so I'm going to click on the little circle on the bottom, and there's more than one way to do this, but I'm going to click on the little teeny tiny circle on the bottom of the pill and drag a line. And I'm going to choose a shape. I'm going to choose the tilted diamond, the tilted rectangle, the parallelogram. And I'm going to add some text here. Input username. If you need to break the text, add a character turn, don't just hit enter, hit control enter. If you hit enter, it just saves the text you've already added. All right, now I'm going to draw another line. I'm going to use the diamond shape, the if statement, if username, and then I'm going to hit Control Enter to give myself more space, equals Joe. Then I'm going to hit Enter rather than Control Enter. And now I'm going to draw a line from the right side. So I'm going to click the itty bitty little circle on the right side, and I'm going to make another parallelogram for a print statement. And I'm going to make it say print hello Joe Control Enter. What do you, Control Enter? No. Strictly speaking, you may not need to enter all the Control Enters. It might resize the text appropriately. But if it doesn't, letting you know how to do it. Okay, now that looks kind of tacky. That line is going into the side of it rather than the top. So I'm going to rearrange it a little bit. I'm going to drag that box down. And I'm going to try to grab the arrow. So I'm going to click on the word yes. And then I'm going to click on the top, the end of the arrow, the arrowhead, and drag it so that it goes to the top of the parallelogram rather than the side.
What does the text say?
That says yes. Sorry, let me zoom way in. And this is still looking ugly, so I'm going to stretch the box out a little bit to make it all the text fit. So I'm going to click on the parallelogram, I'm going to grab one side or the other, and I'm going to stretch it out until all the text fits comfortably. All right. I'm not going to add an else statement to this, so I'm just going to draw a line straight down. If I was adding an else, I would make a line go to the left. But there's no else, so I'm going to draw a line straight down. I'm going to add one more parallelogram. This one's going to say print done. And then I'm going to add one more, a pill shape that says stop. All right, now this is kind of silly because this ends here. So click on the parallelogram that says hello Joe, what do you know? Click on the bottom circle and draw a line over to that print done statement. It could hook up to the side or it could hook up to the top. Kind of your preference. Okay, so that's our flowchart. I mean, obviously you can't read the text now that I've zoomed so far away. And you can rearrange the boxes, you know, to make them fit more comfortably. But my flowchart looks like this. It says input username in an input box up at the top. Then it's got an if statement that says if username equals Joe. The yes side of the if statement says print hello Joe, what do you know? The no side, there's no else, so it's just dropping straight down. And then it says print done. And then there's a stop box. And you can spend hours making these charts pretty. Or you can just use the themes. I'll show you where the themes are. Come up and click. You know, you see this little A with an underscore here? Then there's this thing that looks like 3 rectangles piled on top of each other. Click on the 3 rectangles and choose a theme. If you like straight lines, or you like curvy lines, or you like right angle lines, you can choose any of those, and it'll also choose a color for you. Okay, so that made it look a lot better. I didn't choose a color for them, but I chose the right angle lines rather than the curvy lines, and it made it look a lot better. And I'm going to choose one with a color on it, just for grins. There we go. Now we're back to the curvy lines. That looks pretty lousy. If you want to turn a curvy line into a straight line, you click on the line. So here I had a curvy line that said yes. And then you click on the curvy line up here, and you can choose to make it straight instead. The little curvy line next to the pin color. And I can make it a straight line or a right angle line. And I'm going to do that to the one underneath it as well. I'm going to click on the line, come up and choose the curve up in the toolbar underneath share and window, and I'm going to choose a right angle line. And again, this is just picky stuff to make the chart look better. I don't care how good your chart looks like as long as it's got the boxes and the lines. And then I get some weird little curves between the if statement and the print done underneath, so I'm just going to turn that into a straight line. Hope that fixes it. Yeah, that looks pretty good. I can move the boxes more close together. You don't need to do that. The only reason I do that on screen is so that I can fit more on the screen at the same time, which lets me zoom in to make it easier for y'all to see. Okay, so if you came in late, you go to our D2L page. There's a link to create an account. add your name to it, and also add 113A, 1113A, so that I know which class you're in. Then you can make a new document and you can start practicing drawing flowcharts. Alrighty. That's our first flowchart. If you want to print it, let's not print it. But you can do, yeah, we will print it. It will print it as a PDF. Firstly, let's click Save or Save As, and let's give it a name. Like, my first flowchart. Not really your first. I think you drew one in class, but, and then click OK. I did that from Save or Save As. And now do File, Print, and it'll create a PDF that you could email, that you could submit to a Dropbox. It's got a horribly long name. I don't think that it needs that name. I think we're on in-class assignment I once I make a folder for it. So just call it inclassi.pdf. And wherever you saved it, you can find that and upload it to the Dropbox I'm just about to make.
You want to put a name when you were running?
Yeah, when you save it, I mean, as long as it goes in your Dropbox, I know that it's yours. So I'm not real picky about names. But you may as well. Yes, sir.
What were the ones you did?
Okay, saved it yet? Go file, save.
What were the ones you did?
Oh, I am so sorry. Print done and then stop. So print is a tilted parallelogram, stops at the top of the hole. Yes, sir.
I couldn't really see it there.
All right. Let's rearrange these just a little bit. I'm going to put start above it all. And put username. That's not so cool. Draw that line. I'm going to click on this and I'm going to drag the top of it to there. Whoops. Fine. I'm going to put it back on this one. Drag it over there. We're going to make that say yes. The decision is to say if name equals Joe. We can say print hello Joe, what do you know? Down here, we're going to print done. Let's add the word print in front of it. Cool. And lastly, just make that say stop. Okay, now you can zoom in and out by holding the control key and spinning your wheel. And the only reason I'm doing this is so that I can grab it all and pull it down on one page rather than two. Then do a file save, which you may already have done, and then print, do print and save it as a PDF to your hard drive. All right. Sorry. You have to do a print. Sorry about that. Once you do a save, then you do print. And that actually saves it as a PDF. Maybe. It's not asking for a name. See it though. Well. It's not offering a chance. It's just doing it, so you can rename it once it's on your desktop. Yes, sir?
I'm not sure what it's saving to. I'm trying to print.
Yeah, good question. It's, what browser are y'all using? Okay, then now this one actually let you to say, it's not offering you a save dialog when you hit print, that's kind of bizarre. In just a sec. Alrighty, I'll create the Dropbox, we can upload it. If you need more help, raise your hand, or maybe your neighbor will help you. Right, do file print, and it should bring up a dialog with a save as. If it, for the PDF, if it for some reason does not, then go to your downloads menu in your browser. In Chrome, it's this little pull down box with the 3 lines to the far upper right corner. You can choose downloads, and then you can click show in folder. It'll show you where your PDF was saved. You can rename it. All right, time for Dropbox. All right, refresh your Dropbox. It'll be under the in-class assignments as in-class I. And upload your PDF. And if you can't find your PDF now, then let's wait until the end of class and I'll help you find it. All right, now we can draw flowcharts to our heart's content. I can assign them to you. I can inundate you with flowcharts. Earlier versions of the class, the people drew flowcharts through, almost the entire 18 weeks, or whatever, 16 weeks, but we're not going to do that. All right, I wanted to start lecturing again from head first, but there's a little bit more we need to do, so I'm on Think Like a Computer Scientist, so I'm going to hit chapter 5 again. There may be something else we need to do in there. Okay, we were talking about logical operators, and, or, and not. I think everybody has the idea of and or from our earlier lectures. And simply means that both sides of the expression have to be true for the result to be true. Or means either side of the expression has to be true. Then there's a little thing called a truth table, and I've kind of drawn these before, where you have an A and a B, and then you have A and B. So the only result that gives you true if you're using an and statement is if both sides of it are true. On an or statement, A or B, the only time it's false is when A and B are false, because for A or B, for it to be a true statement, only either side can be true, either or both sides. And then there's not. The word not just flips the truthiness of the expression that follows it. So if you say not A, then if A was false, it becomes true. And if A is true, it becomes false. And when I say becomes, it doesn't change the value of A, but it evaluates as A. So conditional execution, that's a fancy word for an if statement. Now if you take the modulus of something and divide it by 2, if you modulus 2 a value and you get something greater than 0, you know it's an odd number. But if you modulus 2 something and you get a remainder of 0, then you know it's an even number. Like 2 modulus 2 is 0, 10 modulus 2 is 0. So that's a real quick check to see if something is even or odd. All right. Did you know that 2 is the only even number that is prime? Nah, I'm glad to know that. Okay, so here's an if-else statement. If x% 2 is equal to 0, print it's even, print something else. Else, print it's odd. Okay, so if you do an if-else in a flowchart, you don't have to draw this unless you just want to. It kind of looks like this. I'm going to just put an empty box up here, I don't care. And then you put your if statement. If x modulus 2 is equal to 0, I'm going to put my yes side on one side. It doesn't really matter, but I like going to the right. And my yes side is going to print it's even. So I need another parallelogram. Print x is even. And you can make your code look as much or as little like programming language as you wish when you're drawing a flowchart, because you're not actually, this isn't real programming. This is just diagramming logic. And you can use a flowchart for any language. So if you want to make your statements look like Python, that's cool. Or if you just want to word them in English like we did over here with no special parentheses or anything, that's also cool. All right, but this one did have an else. So I'm going to draw a line over here, and instead of making it say no, I'm going to make it say else. Now that's not strict flowcharting rules, but it helps me remember that this code is going to go in an else block. And the else statement is going to be another print statement that says print x is odd. Then I'm going to stretch them back out, and they need to rejoin. Because now both code blocks are done. And then whatever's at the end of that, I don't care if it's a stop or whatever, I'm just putting that there. Okay, so there's my flowchart for a conditional statement with an else. I put the word if here, and strict flowcharters don't do that, but I like seeing the word if there because I also use the conditionals for while statements and for statements. And if that's true, then I put the word yes, and I put the code block for the if statement in there. If it is not true, I put the word else there, or you could put no. Either one is correct, but I like putting else there to remind myself that's inside an else block. And you put the code block there. And then you draw 2 lines hooking back up into whatever's going to happen next. So let's compare this, if I can, to that code that I just saw. Here. Okay. Now it doesn't have to say stop. That's just what I made it do here. It's whatever statement follows in the code. And in this little block of code, there was no statement following it. So if x% 2 is equal to 0, if x modulus 2 is equal to 0, that's my if statement. Then I put 1 or more lines of code in that if block right there. And it's indented to show that all that executes until it hits the first unindented line. And in this case, I didn't want to print, did you know that 2 is the only prime number? So I only put 1 print statement in the yes side. Now we're done because we stopped indenting. So that means that this is the only stuff that gets executed by the if. And we've seen if else, in our dice games or whatever. Else, print x is odd. And then once we're done indenting again, the else block is over. And so whatever was, line number 8 or whatever here would follow on the flowchart. So the flowchart, is a mental map of the picture. And they differ significantly. Just like if you Google up directions, to Bricktown or something like that, it's just a straight series of instructions. Whereas a map, it's a 3-dimensional layout. So there's not really a one-to-one correlation between this and this in terms of their positioning in the code. But logically, They represent the same thing. Okay, here's how Think Like a Computer Scientist recommends flowcharting an if statement. I like mine better. Sure enough, you can replace the word yes with true if you like. You can replace the word else with false if you like. Flowcharting is for your use and for the use of the people you're working with. And if they understand what you mean, that's good. I want to use else here. If you do your flowcharts and you put an else there, that's going to make me happy, but I'm not going to count off if you put false or no or whatever. You know, Lucidchart likes to put yes and no, so yeah, whatever. True, false, yes, no, yes, else, totally good. Here I use tilted boxes, and they used rectangles because this is a generic version of it. All it says is condition up here. I add the word if to my decision block because I use the same shape for while statements and for statements. So I would have put if space condition if I was making a generic flowchart. They use straight lines. Lucidchart defaults to curvy lines, whatever. So that's a conditional statement, more commonly known as a flowchart. Omitting the else clause. This is what we did in the flowchart we drew. If there's no else, you just drop a line straight down because there's no code being executed over here. So change conditionals. That's a weird term. I haven't seen it in too many textbooks, but this one uses it. A change conditional is when you have more than one if statement following each other. If you're going to do that, you use if on the first one, and then you use elif. Other languages use else space if, but Python made it one word, elif. Elif Fitzgerald. I don't know. Elif, and then the last one is an else. And you could chain as many if statements as you want, as long as the logic makes sense. You know, if grade is greater than equal to 90, print A. Elif grade is greater than or equal to 80, elif, print B. Elif fail. In this class you have to make an A or a B or it's just all over. And I'm kidding. So here is a flow chart of this change conditional. Now this just looks really lousy. It's getting kind of cluttered, but really that's kind of what you have to do. And again, I would use the word if and elif to make it absolutely clear what I was doing. So if I was going to diagram my little code that I just told you about if 90 is an A, if 80 is a B, it looks something like this. I'm going to draw another one. Here's my conditional. If grade greater than or equal to 90, I'm going to print A. And I'm going to drag this way out because I know that I have another else coming up. Else, or elif, I'm actually going to put that in the decision block. Elif grade is greater than or equal to 80, print B. Or you made a B or whatever, And then lastly, if none of those are true, then I'm going to add an else clause down here at the bottom. So I'm going to change that no to the word else. And these are all just my own individual quirks. I don't care if you follow the rules that are shown in that textbook exactly or if you follow my style. Even though mine is far superior. And I'm modest. Nobody's laughing at my jokes today. Wake up, y'all. I usually trust Corin to laugh at my jokes. You're glaring at me. Why did you call me out by name? Okay. And if neither one of those conditions was true, then our else says print F. Now we need all the lines to hook back up together, because we're done with our series of else statements. Did I say elf statements? Lord of the Rings programming. Okay. If you want to reshape these curves, you can do that with some of the symbols up here. I think just making them right angles will fix the problems that I'm seeing in my flowchart. And then I need some box underneath here, you know, whatever the next statement is, whether it's a stop or who cares. All right, there's my if, elif, else series. If grade is greater than 90, print you made an A. Elif grade is greater than 80, print B. Else, print F. And then whatever statement comes next, you know. And again, you know, you have to kind of figure out how you're going to, you know, position these things. It can be kind of a drag figuring out how to position all this. And flowcharting was invented long before programming was really, so there's really no one-to-one correspondence to the statements in a flowchart and the statements in your language, which is why I add words like if and elif and else to make it more closely match. And so let's do this in code as well. Knock this over to the side. Pop open idle. And I'm not going to make you turn this in. You don't have to type it, but if you want to practice, it's certainly nothing wrong with doing that. Okay, first I need a grade variable. So I'm going to say grade is equal to 85, just so I have a grade variable. Now I need my first if statement. If grade is greater than or equal to 90, colon, print, you made an A. Elif grade is greater than or equal to 80, print, you made a B. Else, print, you made an F. Seems harsh, but whatever. Okay, print, done. Now I'm going to run it. Make sure you don't save it to your Python directory as always. Put it on your desktop or something. I'm going to call this elif.py. That may be a bad idea. Okay, it's giving me invalid syntax because I forgot to put a colon after the else statement. Each code block you have where you start indenting has to be preceded by a colon. Doesn't matter whether that's a while or an if or a DEF statement. Every time you start indenting a new level, you need a colon before it. And I forgot my colon on my else. All right, you made a B. Done. Of course, I could change the grade to a 95 or something like that, and I could change my grade to a, you know, a 70. Make sure that all the available roots work. But that matches my flowchart pretty good. I'm going to see if I can make my text larger in my flowchart. I'm going to highlight everything with Control A. And then over here where it says 8 points, I'm going to change it to 9, 10, 11. I can't say that I think that that's actually doing anything. Let's try that again. No. What, I have to do each one individually? Yeah, that's bizarre. Okay, that's made my if statements look all tacky. It doesn't all fit in one, but whatever, you know, there. Just trying to make it easier for y'all to see. So y'all see the correspondence between the graphical logic and the code. I try to make this look as much like the code as possible, which is why I don't make lines going out to the right, excuse me, the left of the if statement, unless I can avoid it. I really can't avoid it, you know. Because here you don't have code popping off to the left, you only indent to the right. do you do if you get to the bottom of a flowchart and you need to keep adding code? Well, you could just, start drawing on the next page. This thing supports multiple pages. Or you can start, a new chain of command, a new line of logic blocks, and just draw a line from the bottom one here to the top one there. Now, if it's a curvy line, that looks kind of lousy, so I'm going to change that into a straight line with the curved thing next to the pencil. Well, not a straight line, but a right angle line. And then I can, draw it like that. Okay, so now it's pretty clear that when I hit this statement down here at the bottom, I just zip right up here and keep continuing. Now, that doesn't mean anything code-wise. There's no line, there's no go-to statement or anything like that. It's just, like pages of a book. You hit the bottom of a page, you go to the next page, and you keep going. There's a little indicator that you're supposed to do if you have to go to a new page, and that's a little circle. You could put page 2 down there on the little circle to indicate that you're going to a different page. I don't know if we're going to be drawing any flowcharts that are multiple pages. Oh, by the way, if you check your grades, you will have a final grade assigned according to all the things that I have graded this morning. Check and make sure that you have a grade for every assignment you've uploaded. And of course, that's not really your final grade. If you keep turning in assignments, your grade's going to maintain the same or go up. And if you stop turning in assignments, your grade is going to plummet. But, it's where you are right now. It's kind of like a slightly after midterm grade. Okay, nested conditionals. Nested conditionals get a little bit uglier, but it's when you put an if statement inside an if statement. This is not when you use elif. This is just when you put an if statement inside an if statement. So I could do something like this. If, college is equal to true, meaning that they went to college, and if employed equals true, then I can print you qualify for the discount. And it seems kind of rude to only give them a discount if they're employed, because it's the unemployed people who need the discount. But, these same people who made us fail if we made a C must have designed this logic. Okay, so that's a nested if statement. And you can also nest if statements inside your else. Else colon, if, whatever. I don't think I'm going to take the time to flowchart that, but you just put another diamond, on either the true side or the false side of your conditional. So if college is equal to true, then you come over here, and then you have another diamond that says if employed is equal to true. Now, both of those conditions have to be true before we print you qualify for the discount. There's a better way to do that, though. If you have some nested if statements, think about whether you can use the and word in order to make this better. I could say if college equals true and employed is equal to true. And by the way, you don't have to say equal true. You could just say if college. It assumes that you're comparing it to true if it's a Boolean variable. And you could say if employed. So I'm going to rewrite this code so that it uses an and statement, and it's no longer a nested if, because nested ifs are harder to draw. And, code looks a little bit more complicated. So if college, am I going to put equal true or not? Somebody pick. Did I hear a yes or no? Come on, somebody vote.
Yes.
Yay! All right. If college is equal to true and employed is equal to true, colon, then print you qualify for the discount. There we go. So I have replaced my nested if statement with an and. Here's their example of a nested if statement. If x is greater than 0, if x is less than 10, print x is a positive single digit. Again, you could replace this just with an AND statement. If x is greater than 0 and x is less than 10, print x is a positive single digit. Lots of times, if you have a nested if statement, try to think if you could word that with an AND statement, just to make the logic a little clearer. And there's our example of that. If greater than 0, I mean, he worded it backwards, if 0 is less than x, but I like putting the x on the other side of the sign. If x is less than 10, print x is a positive single digit, or we can use the AND keyword. If 0 is less than x and x is less than 10, print x is a positive single digit. The return statement. Seems like we've already talked about return statements, so why are we talking about it again in conditional statements? You can stick a return statement inside an if, like that. So print square root. Inside the defined print square root function, it says if x is less than or equal to 0. And the reason for that is the square root of negative numbers is kind of a funny business that give you something called imaginary numbers. If you've ever taken a math class that talks about imaginary numbers, that makes sense. If you haven't, that's totally okay. Imaginary numbers sound singularly useless, but if you're an electrical engineer, then that imaginary number represented by I actually gets used. So here's their logic. We want to take the square root of positive numbers only. So we have an if statement that says if it's less than 0, positive numbers only, please. Return. That bails us out of the function early. I wouldn't word it like that. I would use an else right there, and then I just have one return at the bottom. The fewer return statements your function has, the easier usually it is to figure out the logic. But sometimes it makes sense. You do some error handling up at the top to make sure that you got some good code, some good values, and then you can put 100 lines or 1,000 lines or whatever, trusting that you were given good data at the very beginning. So that is a common programming paradigm. Make sure that your parameter is valid up at the very top. If it's not valid, print an error message and return out of it, and then the rest of your code can follow. But you can always word things more than one way in a programming language. We could do this. I'm going to just copy and paste that function. There we go, but I don't like having a return statement in the middle. Let's say I'm just prejudiced against that. So I'm going to use the word else to fix that. And then I could put on that unnecessary return statement at the bottom. Now to me this looks like better programming because there's only one way out of it. However, I do use that other means a lot, where you have the return statement right after you validate. Because, it saves you an indentation level, simply. If you return right here, you don't have to indent everything under your else code. But it makes your flowchart look nastier. You have two ovals coming out of your function. You have one return here up at the top, you have another return there down at the bottom. It's up to you. Logical opposites. Equal, equal. What's its opposite? I've got to highlight it, so that makes it pretty easy. So if you're saying if A is equal to B, and then you decide you want to see if the opposite is true, then how would you word that? If A not equals B. If you decide you want to see if A is less than 0, you could do A is less than 0, but then later you want to check the opposite. What's the opposite of A less than 0? Yeah, greater than or equal to. Not just greater than. You also have to check the equal. Okay, and if A is less than or equal to, the opposite of it is greater. If A is greater than B, the opposite of that is if A is less than or equal to B. Why do you have to include the equal? You just have to make sure that you get, that midpoint. If you're comparing x to 0, that means that anything less than 0 but not including 0 counts. but you do if x is greater than 0, that means you say if anything greater than, but not including x is 0. So if you want the opposite of this, strictly speaking, you need to include that 0 as part of your opposite statement. So that's why when they flip it, they either add the equal sign or they remove it to make sure that you're handling that 0 condition correctly. Then there's something called De Morgan's Law. I'm debating whether to make you memorize this term, especially since our next exam's a little ways off. But what De Morgan's Law says is that if you're going to write a statement with an and or an or, but you want to put the opposite, here we did opposites with single expressions, equal equal become not equal. Then you have to change both the word and to or the word or to and then you have to make the conditions opposite as well. Let me give you an example. That sounds pretty abstract. Okay, so I think I've given you this example before. How do we define a teenager? A teenager is anybody who's got the word teen in their name. That's going to be my definition of it. I really don't think of a 19-year-old as a teenager or an 18-year-old, but we're just going to say that anybody with teen in their name is a teenager. Okay, so if age is greater than or equal to 12, no, 12 doesn't work, 13, and age is less than or equal to 19, colon, and you can leave the parentheses out in this language, not in a lot of other languages, then print teenager. What if I wanted to word that so I want to print not a teenager? So I have to flip the logic. De Morgan's Law says that to flip the logic, not only do I have to change these greater than equals and less than equals to their opposites, but I have to change this word and to or. Because here we are checking a range of values between 13 and 19, but now to see if I want to print not a teenager, I need to reverse the logic of it completely. So if age is less than 13 or age is greater than 19, colon, print not a teenager. All right, so this is an example of De Morgan's Law. We had an expression with an and. We decided we want to flip it so that it's not merely, less than or greater than. We want to get the opposite result. We had to flip both the comparators, the comparison operators, the less than and greater than. We had to make them the opposite, and we had to change the word and to or. And then we got the opposite result. That's just a real easy, well, maybe it doesn't seem easy, but that's the shortest way of making an expression evaluate to its opposite. There's also another really easy way. What if you just add the word not in front of it? I could take this expression here, I could paste it, and say if not, print not a teen. That works as well. There's always more than one way to code something. I don't know whether you like this logic better, if you like putting the word not in front of it, or if you like rewriting it with De Morgan's Law. It's up to you. If you're a Trump supporter, you probably like one. No, I'm totally kidding. Which way you like better? Which logic is easier for you to read? If not, followed by a complex expression, a compound expression, or if with the compound expression flipped using De Morgan's Law? Which makes sense to you? I should make everybody vote. Raise your left. No, I'm not going to. Type conversion. If you're given a string, you have to convert it to a number before you can do the comparison. We've already done that like in our dice game. What was your dice roll? 7. You had to turn it into an integer or a float before you could do the comparison. you do that conversion with the int keyword, the int function, or the float function. A turtle bar chart. This is kind of fun. It'd actually be fun to make that happen. Maybe next class time. This would be more useful though if, well, anyways. We'll keep that in mind and we'll come back to bar charts. Hey, that's cool. They're actually putting words on top of their bar charts. And that's using t.write. I had kind of forgotten that you can make the turtle write something as well as draw shapes as you were going. That's pretty slick. We definitely need to do that. Ooh, and now a color flow chart. Who needs Excel when we can use a turtle? Yay, I got a laugh out of it. All right. What is a code block? It's a group of consecutive statements with the same indentation. I would say the same indentation or more, you know, because all of this is a code block from here to here, you know. Not just everything that's indented, that level, but the one that's inside it and the ones inside it. However, this is a code block in unto itself, that one statement, because that's indented at that level. This is a code block unto itself. That's a code block unto itself. But if we made this a function, define grader, that takes a variable called grade, colon, you know, and then I asked you to point out where all the functions, where all the code blocks were. There are, how many code blocks do we see? I see 4. This whole thing is a code block that is attached to that function. This first print statement is a code block that's attached to that if statement. The second print statement is a code block that's attached to that elif. And that third code block is the print statement that's attached to the else. So it's just the levels of indentation. If you wanted to draw a box around all of this, then that would be one code block because it's all indented at least that level or more continuously. And then you have 3 subcode blocks that are attached to the if statements. Boolean Algebra, rules for rearranging and reasoning about Boolean expressions. Yeah, we haven't really covered that. But a Boolean expression is something that's either true or false. It can either just be a variable, you know, if college, or it can be more than that. If age is greater than 9, if temperature is less than 32. A Boolean value, there's exactly 2 Boolean values, true or false. In the olden days, programmers would make a variable that equaled 0 or 1, and the 1 meant true, and the 0 meant false. But now, they actually use those words, make the languages easier to read. A branch. A branch is a possible path of flow of execution determined by the conditional. If something, then print something. Well, that print something is a branch. If you have an else clause or an elif clause, you have another branch. A change conditional is a series of if, elif statements. Maybe it only has one elif, maybe, you know, it might not have an else statement at the end, but if it's got more than one condition in it, it's known as a change conditional. Comparison operator. There are 6 comparison operators. I heard somebody yawn. Don't do that. You're making me sleepy. Kidding. Equal, equal, not equal, greater than, less than, greater than or equal to, less than or equal to. That's a comparison operators. The condition is a Boolean expression in an if statement, a conditional statement that determines which branch is executed. So I'll say, what is the condition of this if statement? Or I may say, what is the conditional expression? And you tell me whatever was after the word if, or what was after the word while. The conditional statement. A conditional statement is one that uses the words if, elif, or else to control the flow of execution. You're going to execute some statements. If the condition is true, you're going to execute A. Now, I heard that yawn. That one was pretty loud. You're putting the entire class to sleep. Then you have the logical operator. Logical operators are the words and or not. Nesting is when you put an if statement indented under another if statement. What is a prompt? A prompt is when you ask the user to enter some data. It tells the user that the system is ready to accept some data. Data? I don't know what I was about to say there. So I think I was combining the word data and input. Datum input. So, enter your age. That's your prompt. Are you 18 or over? That's a prompt. What is the temperature? That's a prompt. How many pounds of sugar? That's a prompt. Truth table. That's that thing where you put the, the truths and the falses and what they result in, either with an and or an or. Type conversion. Type conversion is turning a string into a float or an int, something like that. Wrapping code in a function, also known as encapsulation. It's when you take some code and you put it into a function so you can call it multiple times, like our circle statement. By the way, I got one smiley face drawing where the draw circle function was defined like 10 times. And I couldn't figure out why they did that until I noticed that they had called draw circle 10 times in their circle, in their smiley face. You only need to define the function once. You could call it 1,000 times. You only need to define it once. That's the reason you made it a function, is so that you could just define it once. Write once and then use many times. Alrighty. I hadn't really cooked up a homework assignment for today, so I think we'll wait until Wednesday to assign one. But we have a whole 7 minutes left. What are we going to do? We're going to talk about how to flowchart a while statement rather than an if statement. A while statement is very similar to an if statement. It is a conditional, but the code gets executed over and over and over until that condition is no longer true. So you could do something like this. Ask the user for their name. Input name is equal to, excuse me, I'm completely wording that wrong. Name is equal to input, what is your name? We ask for their name. And then we check. While name not equal to Joe, colon, print, are you sure? I think your name is Joe. And then we're going to ask them again. We're going to keep asking them until they give in and say that their name is Joe. Yeah, it's stupid. Okay. Name is equal to input, what is your name? This will be the last thing we do. Alrighty. It's like an if statement, but as long as this condition is true, it's going to stay inside this code block. It's not going to leave it until it becomes false. So if their name is Joe, if their name is not equal to Joe, we print, are you sure? I think your name is Joe, and we ask them again. Name is equal to input, what is your name? Once they finally type in Joe, this condition finally becomes false, and it'll exit the while statement. Here is how I would flowchart that. Same diamond for a decision, but I would use the word while in front of it. So let's do this. La-di-da-di-da. Name is equal to, what is your name? I forgot to put the word input in front of it. Okay, now we have their name. Now we need a conditional, so I'm going to use a diamond. If name not equal to Joe, except it's not an if statement anymore, it's a while statement. While, space, name not equal to Joe. Then we're going to print out a message that says, liar. You lie. Like a rug. Okay. And then we're going to ask for their name again. And we need some way of indicating that we are now going to repeat the while statement. So I would just draw a loopy line back to the while statement like that. And then I would use one of the tools in order to reshape that loop. Haven't shown you how to do that, but I'll do that when we need to figure out how to redo our curves. Man, I hit escape. That lost it. Okay. And then, once it's no longer true, then we're going to come and do something else, or just stop, whatever. Okay, so there's my while loop flowchart. Name is equal to input. What is your name? While the name is not equal to Joe, then we print you lie. Name is equal to input. What is your name? We ask them again, and we go back up here. So all of this is indented. And then finally, when you stop indenting your code, the while loop is done. Just like I showed you over here. Right there. This matches the same flowchart, except that the messages are different. Name is equal to input. What is your name? While name is not equal to Joe. It stays trapped in that while loop until they finally type Joe. Once this condition is no longer true, then it goes to the next unindented statement. Does that make sense? All right. We can leave a whole 2 minutes early, or we can stay after and talk about stuff. I didn't take roll, but I'm going to take it based on what you upload into the Dropbox, so everybody make sure they put a PDF. If you didn't put a PDF up there, at least upload a text file so that I know you were here today. Just put, I'll do the PDF later, something like that. Or if you typed in a script, you could upload that, show that you participated in the class.